Hello student, hi, good evening. Today we are going to discuss about the concept of transient, and here we are going to see the transient circuit for multiple switching case. Okay, so we are not seeing here the single switch that you might have seen, and you are much more comfortable with single switch transient circuit. Here I am going to show you the two switch case at which are on at a different time. Okay, so this means that we are going to see the transient circuit for multiple switch which is on at a different instant of time. Okay, so let's see here by taking one problem, and we will understand the concept of multiple switching transient circuit. Okay, so let's see here. My question is here about multiple switching transient circuit. So this is my circuit. Let's say this is my current source, and this is my resistance of 200 ohm and 200 ohm, and this is my 75 milliampere of current source. Okay, so then here is one switch is connected here. Okay, so this is my switch A, which will on at time t is equal to what? 0. T is equal to 0. This switch will on, and here is another switch, which is switch B. This is my switch A. Okay, so this switch will close. Yes, so this switch will close at t equal to 0, and this switch will open. This is my switch B, which will open at time t is equal to what? 25 millisecond. Yes, millisecond. And here is another resistance of 500 ohm, and here is my inductor of 10 millihenry. This is my 10 millihenry inductor, 10 millihenry of inductor. Okay, and this is my ground. Okay, so this is what our circuit, and we have to find here current IL of t. Okay, for t greater than is equal to 0. Okay, these are the two switch A and switch B. Switch A is what? Switch A is going to close at time t equal to 0, and switch B is going to open at time t is equal to 25 millisecond. Okay, so for that what we have to calculate, calculate the current that is passing through the inductor, for time t greater than or equal to 0. So now see how to solve this question. You might have seen more number of times the single switch case, but here we are going to do the two switch case which are closing and opening at different time of instant. Okay, so we will see it with proper manners, and I will show you how to solve this type of circuit. Okay, so once you will understand this technique, and you can apply this to all the other circuit of multiple switching of transient circuit. Okay, so that is what. So let's see. Let me rub this first. Okay, so this is now here for first case. What we are going to see in first case, we are going to see this circuit for time t less than 0. Okay, t less than 0 for long time. For long time means what? For long time means it will reach at steady state. Means steady state. This is my what? Steady state. Okay, steady state. Steady state means here what? Steady state means t is approaching to minus infinite. Okay, t is approaching to minus infinite, and this is my steady state. As you know very well, in steady state my circuit will reach to what? As we know very well, for long time, for t less than 0, my circuit will reach to the steady state. Okay, steady state means very long time. Okay, so it is approaching minus infinite time where this circuit will go in steady state. Okay, so let's see here. I'm going to rub this, and you just note this circuit, and after that I'm not further going to draw this whole circuit. Okay, so I will just draw the circuit according to switching condition. Okay, so first you note down this, and then after that we will see the case for t less than 0. Okay, so let me rub this first. This is my first case. We are going to draw the circuit for t less than 0 for a long time, where the circuit will reach to what? Steady state. So let's see. So this is okay. Let's see what is our first case is what, t less than 0. Okay, so where t is approaching to minus infinite means our circuit is reaching to steady state. As we know very well, in steady state, what happens in steady state? In steady state, as we know very well, in steady state, inductor will get what, short circuited. Inductor will get short circuited and capacitance will get open circuited. Okay, open circuited. Inductor will get short and capacitance get open. Okay, in steady state. So let's see, but here in this circuit there is no capacitance, there is only inductor, so that we are going to short for time t less than 0 at equal to minus infinity, which means steady state. Let's see how to draw the circuit for steady state for long time for t less than 0. So this is my current source of 75 milliampere of current, and here is my resistance. Okay, and this is my switch. This is my switch which is open, still open. This switch is open and this switch is closed. Okay, closed. This is my switch A and this is my switch B. Switch B is closed and switch A is open. So, and this is my resistance of 500 ohm and this is my resistance of 200 ohm. Okay, and this is my inductance which will get short in steady state. Okay, so therefore I will calculate this inductor current for t less than 0 for a long time. That means IL of 0 negative I am going to solve. If you see here, this inductor is shorted, this means this is short. Yes, due to this resistance, these both resistance will get eliminated. Okay, so will get eliminated means this will get automatically what, eliminated, means there is whole current will pass through this short circuit. No current will pass, because you know very well the current always see the short path to flow. It will see this short path, so that this whole current will pass through the short circuit and there is no current at all. Here the current is 0 ampere and here also the current is 0 ampere, and my IL of 0 negative will be equal to 75 milliampere. Yes, this is my 75 milliampere of current is passing through this inductor for t less than 0 for a long time in steady state, which is IL of 0 negative. Okay, so now we have calculated the value of inductor current in steady state for t less than 0, which we obtained as 75 milliampere. Okay, so now see, we have calculated the inductor current at time equal to 0 negative, which is nothing but a steady state current for t less than 0. Now we have calculated this current IL of 0 negative is equal to 75 milliampere. Yes, milliampere. This is my inductor current. As we know very well what the inductor, as we know very well, this inductor does not allow the sudden change of what, current through it. So therefore sudden change of current is not allowed through the inductor, means inductor does not allow the sudden change of current through passing through it. This means that what, this means that IL of 0 negative will be equal to IL of 0 positive, which is equal to 75 milliampere. Okay, so this means that inductor does not allow the sudden change of current passing through it, so which means IL of 0 negative equal to IL of 0 positive, which we got 75 milliampere. So now you know down this value. Okay, so we are going to see the circuit for another case. So let's see. So this is for t less than 0. Now we are going to, you just know down this value. Okay, so now we are going to see the circuit for next condition. So that we have seen this circuit for t less than 0. Now second condition is what? Now the circuit for t greater than 0 but less than 25 millisecond. Yes, we are going to see our circuit for this duration of time, and I'm going to draw this circuit for this duration of time. See, t is greater than 0. Now switch A will close, but if you see switch B is still closed. Okay, still closed. So now see, for this duration of time, my circuit will be what? This is my current source of 75 milliampere, and this is my resistance here, resistance of what? 200 ohm, and this is my switch A. Switch A will now close. Yes, switch A will close, which will close at time equal to 0. Now my time is greater than 0. Now switch A will close, and switch B is still closed. still close, and this is my here resistance, and this is my inductance. This is my inductance. This is my resistance of 500 ohm, and this is my inductance of 10 millihenry, and this is my ground. Now we have drawn the circuit for this duration of time. Now this is very important point. You have to see properly. Okay, so what I'm going to do in this duration of time. Now see, this is the duration of time. Now here again I am going to see my circuit. What I am going to see my circuit for long time. Okay, so for this duration of time, I am going to see my circuit. I am going to see my circuit in steady state for this particular duration of time. Yes, for this particular duration of time, I am going to see this my circuit in steady state. In steady state, what happened? This inductor will get short. Yes, short out. This inductor will get short out. Then what we will find here, IL infinity. So now see, I am going to see this circuit. Okay, so where the switch is closed, now I am going to see this circuit in this duration in steady state, where the inductor get short. Yes, inductor get short. Remember that steady state means t approaches to infinity. This t approaches to infinity means what? This exactly not means that very long time, not means, it is symbolical representation. Okay, it is symbolical representation for this circuit in steady state. Do not understand this like t approaches to infinity means it is greater than 25 milliseconds. No, within this duration of time, I am going to see my circuit in steady state, which means that t approaches to infinity, which is a symbolical representation for this circuit in steady state within this duration of time. This is very confusing point that most of student will understand this, that t approach to infinity within this period means this is greater than 25 milliseconds. It is nothing like that. You have to remember this is a concept. Okay, so it is a symbolical representation. Just okay, so that's why we have to more point out on this. Okay, so in this point, okay, so t approaches to infinity, this means it is a symbolical representation, nothing more than that. Okay, so within this duration of time, so therefore here only I'm going to see my circuit in steady state where this inductor will get short. Yes, this inductor will get short, and I'm going to find my IL of infinity. IL of infinity means steady state current within this duration of time. This is the more confusion that occur in most of the multiple switching case in transient circuit. So that's why you have to remember always this, and this concept is valid for all the other circuit with multiple switch. Okay, so that is what my IL of infinity, which means this is the steady state current within this duration of time, which is nothing but if you see again confusion is there is a too short. Okay, so there is a too short. This is what this short is nothing but this is my tending to short. Yes, this is tending. Inductor is tending to short. Yes, inductor is tending to short. Here this means inductor is tending to short, but this means what? This is a physical short. This is a physical short. Yes, this is my physical short. This is my physical short. This means here inductor is tending to short, and this is physical short. Physical short means which one is already short? This one is already short, so that's why whole current will pass through this circuit. 75 milliampere of current, total current will pass through. See, there is two concept. One we have seen confusion about this. Okay, so steady state, another one is there too short. One is physical short, and this is what inductor short. Inductor short means inductor is tending to short. Okay, tending to short, but this physical short is means this is already short at time t equal to 0. So that's why whole current will pass through this physical short. Yes, physical short. So no current will pass through this. So therefore my steady state current will be equal to 0 milliampere. 0 milliampere. So that is what we have obtained the steady state current for this duration of time through inductor, which is equal to 0 milliampere. Okay, so now you might have learned two concepts here. One is physical short and one is tending short. Tending short means inductor is tending to short, but physical short means this is already short. Yes, this has been already short, due to which the whole current will pass through the short circuit, and the current through this tending short means through this inductor short will be equal to 0, which is my steady state current. Now we have found what steady state current, and we have already found what initial current. Okay, so now we are left with what we are now available with two type of current that we have obtained. One we have obtained initial current. Through the inductor that we obtained how much? That we obtained 75 milliampere. yes, milliampere, and one is my steady state current. Steady state current that we have obtained how much? 0 milliampere. 0 milliampere. Now what we need another what? That is time constant. Just time constant for this duration of time. For this duration of time, how to find the time constant for this duration of time? If you see here, this is my current source and this is my resistance of 200 ohm, and here is my physical short, and this switch is on, and here is a resistance of 500 ohm, and this is my inductance. This is my inductance of what? 10 millihenry, and we are going to find what? Time constant. For time constant, first we will find what? Equivalent resistance, because time constant is what? Tau is equal to L by R. Okay, so we have to know about inductance value and equivalent resistance. Equivalent resistance through this, how much total resistance has been seen through this inductance, that is known as equivalent resistance. If you see, while calculating equivalent resistance, this current source will get open circuited. Okay, so open circuited. Okay, while calculating what? Equivalent resistance. Okay, which is seen through the inductor. How much equivalent resistance is there? If you see, this is physical short, due to which both resistance will get eliminated, will get shorted. So therefore the equivalent resistance will be equal to 0 ohm. How much? 0 ohm. Yes, and we know inductance, that is 10 millihenry. This is how much? 10 millihenry. So therefore over time constant is what? 10 divided by 0 millisecond. Yes, this means what? Time constant is nothing but how much? Something by 0 is nothing but infinite second. Yes, infinite second. So this is what my time constant. Yes, this is my time constant. We obtained the time constant of the circuit. Yes, time constant of the circuit. So now see here, time constant of the circuit for this duration we have obtained infinite second, and we have obtained the initial value of current 75 milliampere, and we have obtained the final value of current for this duration 0 milliampere. Now we are going to find overall current within this duration of time, is that is how much. So let's see what we have obtained here. So therefore the total current within this duration for this circuit through the inductor is given as how much? IL of t is equal to IL of infinity plus what? IL of 0 positive minus IL of infinity into e to the power minus t by tau. Now put all the value that we have obtained. IL of t is equal to how much? IL of infinity 0 plus IL of 0 positive is nothing but 75 milliampere, and IL of infinity 0, and e to the power how much? E to the power minus t by tau. Tau means what? Infinite. Yes, infinite. Something by infinite is nothing but 0, and something raised to the power 0 is nothing but 1. Yes, so that is what finally we obtained the current IL of t is equal to what? 75 e to the power minus 0t milliampere. Yes, milliampere, which means what? IL of t is equal to 75 milliampere. Yes, which is a constant current. Yes, this is my constant current. Therefore for this durations we obtain the inductor current IL of t is equal to 75 milliampere, which is constant. So which is constant. Yes, so this is not overall current. Yes, this is for only for this duration. Okay, now we are going to see the third case, that is our final case, means we are going to see our circuit for t greater than 25 millisecond. Okay, for this duration we have obtained the inductor current as this. Okay, so now we are going to see the third case, that is for time t greater than 25 second. What is our circuit, and that we are going to draw for t greater than 25 millisecond. And here you note down this current IL of t is equal to 75 milliampere, which we have obtained for this duration of time. So let's see further. Okay, so remember all this value, you might have note down it. Okay, so you just note down it, then after that you will collect all the data finally when we will obtain overall current through the inductor. So let's see. Now this is case third. Case third is what? For t greater than 25 millisecond. Yes, for t greater than 25 t greater than 25 millisecond, t greater than 25 millisecond, what is over circuit? So let's see. For t greater than 25 millisecond, my switch is closed. Now my switch B will get open. Okay, so this is my current source. If you see here, which is with 75 milliampere, and this is my resistance of 200 ohm, and this is my physical switch. This is my switch A, which is closed. Yes, closed. This is my switch A, closed, and this is my switch B, which will get open. Yes, now this is open, and this is my resistance here, and this is my inductance. Yes, inductance, and this is my ground. Yes, this is now open. Yes, now this has been open at time t equal to 25 millisecond. Yes, 25 millisecond. Now there is no need of taking this circuit now, because the switch has been closed, the switch has been opened, and it has been separated from this portion. Okay, so this circuit now is what? This is my 500 ohm of resistance. Yes, and this is my 10 millihenry. This is my 10 millihenry. This is my 500 ohm. Now we are going to what? We are not going to draw this circuit. Okay, so this has been separated from this side, because at t equal to 25 millisecond, this switch will get open, and now we are going to draw this circuit only. So we are not drawing this circuit because this is useless now. Okay, so let's see. This is my final circuit. Yes, final circuit for t greater than 25 second is nothing but, this is nothing but here, this is my resistance, and this is my inductance. That's it. Yes, and this is my ground. This is my 500 ohm resistance. Yes, and this is my 10 millihenry of inductance. Yes, so let's see, we are going to find the current. So in this circuit is what? This circuit is source free circuit. Yes, this circuit is my source free circuit. Source free circuit means there is no source at all. So means what we can say now here, then I can say that IL of infinity means current. Okay, so initial current, let's see what is initial. Now for this circuit, what is my initial current? For this circuit, my initial current is nothing but IL of 25 millisecond. Yes, this is my initial current, which is 75 milliampere. Yes, so this is my initial current for this circuit for t greater than 25 millisecond, that is IL of 25 millisecond, because when switch has been open, the switch has been open at 25 millisecond, but at 25 millisecond my current was 75 milliampere. When the time get greater than 25 millisecond, my switch B got open. So, okay, so therefore for this circuit, my initial current is this, and my final current that we will see, my final current is what? My final current is ultimately what? 0 ampere. Why? Because for t greater than 25 millisecond, this circuit is what? Source free circuit. No source is there, so therefore automatically the steady state current means this inductor will get short. Yes, through which IL of infinity is equal to 0 ampere. So this steady state current is for this duration of time is t greater than 25 millisecond. Okay. Don't confuse about the steady state current that we have obtained for the duration of t greater than 0 to 25. Okay, so that is different. That is for that duration. Now this is my steady state current for this duration. Okay, so which we have obtained 0 ampere. Why? Because this is a source free circuit. No source is there at all. So definitely the current is what? 0. Now we are going to find what? We have found initial current. We have obtained initial current. We have obtained final current. Now we are left with what? Time constant. Okay, time constant of the circuit. How we can find the time constant? That we know very well. For t greater than 0, so my time constant is nothing but L by R. L is here, R is here. My equivalent resistance is what? 500 ohm. My inductance is what? 10 millihenry. Now we are going to find time constant, and we know initial value, we know final value. Please note down it, and after that we are going to find the final expression for this duration of time. Okay, so the current passing through the inductor. So let's see what is that. So this is what, see, time constant for t greater than 25 millisecond is nothing but L by R. Okay, where L is what? Where L is nothing but 10 into 10 to the power minus 3 divided by R is nothing but 500 ohm. Okay, so this is this much second, which means what? How much is this? 1 by 50 millisecond. So this means 1 by 50 millisecond. Yes, this is my time constant. Time constant for this circuit we obtained 1 by 50 millisecond. 1 by 50 millisecond. Yes, this is the time constant for this duration of time. Yes, 1 by 50 millisecond. Now we are going to find what? Final current expression for this t greater than 25 millisecond. So let's see. Now we are available with all the current, initial current, final current, and time constant of the circuit. Now for t greater than 25 millisecond, my current expression through the inductor will be IL of t is equal to IL of infinity plus IL of 0. IL of 0, not 0. Here the initial current for this t greater than 0 is 25 millisecond. Yes, minus IL of infinity into e to the power minus t by tau. Now we are going to put all the known value of current here in this expression. So therefore we obtain the current for this duration of time as, see, by putting the value, this is what? 0, and this is 0 plus, and this is my 75 milliampere, and this is again 0, and this is e to the power minus t by 150 millisecond. Yes, t by 150. This will go outside. Yes. Now see here. Just wait. So this is my, because my switch has been closed at equal to 0. So that is what? This is my minus t minus what? T minus 25. T minus 25 by tau. Yes. So this is my t minus 25 millisecond. Yes. This is 1 by 50 into 10 to the power minus 3. Yes, because my switch has opened at time t equal to 25 milliseconds. So that's why it is e to the power minus t minus 25 millisecond divided by tau, and this is my t minus 25 millisecond divided by 150 into 10 to the power minus 3. So this is, therefore we got the final value of current for t greater than 25 millisecond as what? As IL of t is equal to 75 into minus t minus 25 millisecond, that is 10 to the power minus 3 into what? Into 50 will go upside, and this 10 to the power minus 3 at upside it become 1000. So total is what? 50,000. Yes. So this is my final expression. So therefore I am going to write the final expression, this for t greater than 25 millisecond, that we have obtained this. Okay, so let me write this nicely. So that is what? That current for this duration of time we got IL of t is equal to 75 into e to the power minus 50,000 into what? Into t minus 25 millisecond, that is 25 into 10 to the power minus 3. Yes, this is my milliampere. Yes, in milliampere. So this amount of current we have obtained for the duration of t greater than 25, yes, millisecond. Now I am going to write the final expression for the current through the inductor for t greater than 0, including the durations from 0 to 25 and greater than 25. Okay, so that will be my current through the inductor for t greater than or equal to 0. So let's see how to write that. And we know that current also for the duration of 0 to 25, and we know the current for t greater than 25 milliseconds. So therefore, please note down this current first for t greater than 25. Then I am going to write the final expression of the current. Okay, so let's see. What was my question and what is my final answer? What we have obtained. So my question was here: this inductor. This is my current source of 75 milliampere, and this is my resistance of what? 200 ohm. And here is my switch A, and which was initially open, and at equal to 0 this will on. Okay, switch A will on, and this was my switch B, and which will open. Yes, which will close. This will open. Yes, this will open at t is equal to 25 millisecond, and here is my resistance. Here is my resistance, and here is my inductance. So this was the question. Yes, of 10 millihenry, and this is 500 ohm, and this is my ground. And the question was, what is IL of t? What is IL of t? Yes, what is this IL of t current? Let me write this here. IL of t. What is this IL of t for t greater than 0? For t greater than or equal to 0, what is my IL of t? Yes, then we have found the current for both duration 0 to 25 millisecond and greater than 25 millisecond. So now see, we are going to write the total current. Total current is what? Through this inductor for time t greater than 0, we can write as IL of t. IL of t is equal to what? IL of t is equal to what? IL of t is equal to 75 what? Milliampere. 75 milliampere for what? For t greater than 0, less than 25 millisecond. Yes, less than 25 millisecond, and 75 into e to the power what? E to the power minus 50,000 into t minus 25 millisecond. Milliampere. This current was for t greater than 25. Yes, t greater than 25 millisecond. Yes, this is my final answer for this circuit. Okay, so for this circuit, where we have to find the inductor current for t greater than equal to 0. Yes, this was the final answer. You can write this way also, and in the form of unit step signal, I can write this current expression. Let's see how to write this, how to write that one. This is also correct. Okay, so now in the form of signal, how I can write this current through the inductor. Okay, so from this expression. Okay, so let's see how we can write. So see, this is my unit step, u of t minus 25 millisecond, and this is for u of t minus 25 millisecond. Okay, so in this way I can write, and this is also right expression for final current, and another way of writing this expression in the form of unit step form. So let's see how to write that. So that is nothing but here IL of t is equal to 75 into u of t minus u of t minus 25 millisecond u of t millisecond plus e to the power minus 50,000 t minus 25 millisecond u of t minus 25 millisecond. So in milliampere. This is my final expression of inductor current and this is my final expression of current through inductor for t greater than 0. Now there is no need of writing t greater than 0, less than 25, nothing, because everything we have mentioned within in the form of unit step. You see here with the duration of this, my current is 75 milliampere, yes, and for t greater than 25 millisecond, my current is this. If you want to prove also, if you see IL of 0, how much I obtained? IL of 0, put 0 here, this will get cancelled because u of minus 25 is 0, and u of 0 here, this will get also eliminated, this will get eliminated for this 0. So IL of 0 that I will obtain has 75 milliampere. Yes, let's see my final current. My current for what at t equal to 25 is what? IL of 25 millisecond. What is my current at IL of 25 millisecond? My current is nothing but, put here 25 millisecond, this is u of 0, put here 25 millisecond, this become 1, this become what, u of 0. So this is positive, this is negative, this is positive, this again will get cancelled out, and I am left with what? 75 milliampere. Yes or no? 75 milliampere. Yes, this also we have proved, this also we have proved. Okay, so now we are going to find the final current. IL of infinity is what? IL of infinity is what? Here put infinity, put here infinity, this is 1, put here infinity, this is again 1, put here infinity, this is what? 0, because e to the power minus infinity is what? 0. This is 1, this is minus 1, this will get cancelled, this becomes 0. So therefore my final current is what? 0 ampere. Yes, 0 ampere. IL of infinity 0 ampere. This also we have proved, this also we have proved, this also we have proved. Yes, therefore we have cross checked our answer, that our answer is correct or not, our method is correct or not. And this is the way of, this is the way of what? Way of doing this type of solving this type of problems in the circuit theory, in transient. Okay, so in transient with multiple switch. Yes, with multiple switch. And this method is applicable to all the network with transient, which is available with multiple switch, and which is on and off at different time. Yes, that's all for today. Thank you very much.